G'day Fred, how are you?
Good mate, yourself?
Yeah, not too bad. So what are we going to talk about today?
Well, we've developed a little tool to generate random price data, and I want to explain to people how we got there, what we did, and then hopefully on the next video I might show how you can use that to test your EAs and prove to yourself that it's working or not working based on our theory that the price data stream actually has the bias in it, and that's what we're trying to show by going through this random process.
Yes, so in our last video where you showed a tool that we use that uses real market data and then reshuffles that real market data, this is a different process we're applying here where we're actually generating our random data from scratch.
Yep, completely random.
And then we can then apply different assumptions to that data where we insert degrees of what we call bias into that data to test how well our models navigate either the random components or those areas that we've highlighted where the bias exists.
Yeah. So I'm hoping to be able to show how we've done that, and then people can play with it and experience it for themselves.
Sounds great. Okay, so
I might jump on the whiteboard.
Yep.
And let's see how we go from there.
Excellent, mate. Okay, great.
Okay, so what we're going to do now is show you how we got to what we get and try to explain how we got there. And we're going to use a random number generator to do this, but for the point of this exercise, our random number is going to come from a coin flip. So if it's a head or a tail, it'll direct us into a position either long or short. So what we do is we start at a point somewhere. Rich is going to toss a coin, and if it's heads, we're going to move up. If it's tails, we're going to move down. And we're going to move in increments of the same step size. So, Rich, what have we got first up?
Tails, mate.
Tails. So we've got a section down. So price is moving down on that coin toss. So we get the next coin toss.
Tails, mate.
Tails again. So we've now moved down another section. Again.
Heads, mate.
So you get the idea. We're moving up and down randomly. What we've done in this EA effectively is to mimic that. We're taking 1 minute data, so we're taking a decision every minute, and that decision is based on a random number generator, and the random number generator generates a number between 0 and 10. So we've got any possible number sits between 0 and 10, and if it's above the midpoint, the random number that is, if it's above the midpoint we go long, if it's below the midpoint we go short. So we do that 1,440 times. That's how many minutes there are in a day, and we generate this up and down movement, and then we've captured that across a 1 day period. So we know what the start point is, we know where the end point is, we've got a maximum and a minimum, and out of that we draw a bar. And that bar then becomes our daily bar. And so from there, we then take that information and we run the next series through the next day, and the next day, the next day, and that's how we've generated our random data sequence. In order to add bias to this, which you'll see a bit later on, instead of having this set point that we had between 0 and 10 as 5, we're now saying to get a bias to the long side, we want to drop this down to 4 or 3 or some other number, so that if the random sequence sits within that envelope, we go long, or this envelope, we go short. And that way we generate a push to the upside or a push to the downside. So we're affecting the random data and we're pushing it up and down. What we do though is, and you'll see in the demonstration shortly, we're using this same signal sequence to generate our random data throughout.
Okay, well thanks for that, Fred. That's great. So now what do we do now? We bring it to show people how we use this random data for our testing purposes.
Yeah, well let's show you how the script works, which is probably the best place to start. So if you pull up an Aussie dollar chart, and you can see here on the daily time frame we've got this is real market data. You just want to expand that a bit so we can see the bars. Rich likes to use bars as opposed to candles, which is fine. And so what we're going to do now is show you the script that we've developed. So Rich, grab that script. Yeah, so let's just grab this EA or script that we've created. It's called Random Walk, and we're going to dump it on a chart of the Aussie dollar. And there's a number of options in here that we can see, inputs that we can change. The top item there is the date from which we're going to generate this random file. So we're using 2010 as a start date. The scale factor we'll talk about in a little while. And for the purpose of this exercise, we're going to turn everything else off. So we're going to just turn all the biases to off, and that way we'll just generate one random chart, which is of a random nature without any bias. So once we've clicked all that, we hit the go button. OK on that, and here we have, just click that done button there, Rich. So what you see is the red and green is the random data that we've just generated, and the bars below it. And you can see the random nature. That you couldn't probably tell much difference, Rich. I don't know whether you can see the market data versus the real data.
No, the good thing is we notice that the bar sizes are similar. That's using that scale factor, isn't it?
Yeah, the scale factor comes into the bar size, and we'll talk about that in a little while. But for the moment, it's probably suffice to say that the scale factor looks maybe a little bit wrong. The idea here is we've generated a random bar on a step size. Now the question is, what step size should you use? Remember we spoke on the whiteboard about the minute by minute step, and in order to come up with a random sequence that looks like the market data, we've had to use something to get us started. And so we're using the daily ATR, today's daily ATR, as our base point, and then we're dividing that by that scale factor. So let's just run it again, Rich. Grab that same. Now we've saved this as a set file, so you can grab that set file, which we've called random only. And if we use a scale factor of 40 rather than 25, we actually end up with, whoops, where's it gone?
The random does wander, Fred. There it is.
So there's the start point. We've got the same start point, but being random has just taken off completely in a different direction to the Aussie. But you can see now that the bar sizes at 40 are probably better than at 25. We just run it a couple of times just to show that the random nature of what's going on here and how easy it is to generate a random sequence. Bang, we get another random sequence there. Seems to head off in a similar direction. What that seems to be showing now is that the market data is deviating from the random data quite considerably, so there may be an underlying bias there, which is not unexpected.
What's very interesting to me, Fred, is that visually, when we look at this random data versus the real market data, it's very hard to distinguish between the two in terms of their nature, even though their directions might be different. At times we get convergence, divergence between the random sequence and the real market data. It's striking to me how visually I can see all of the same features I see in normal market data within here. So it is incredibly difficult to distinguish between a random series versus a real series visually, isn't it?
Yeah, well see right in the middle of the screen there, in the real market data we see a big dip, and that's something in the market data which is given that a bias. Now we can simulate that by, let's go back and reload that EA again, Rich. Load the random only again. But this time we're going to add just one section of bias. So what date was that one below us there? Roughly, it was around about 2008 by the look of it. So let's
which one? This one?
The one underneath. That,
oh yeah. Let's say it's here. Yep.
So grab that one. Turn that to true rather than false. So now we're going to generate.
Sorry, is it this one?
It's the one above. That's it. We make that true, and now 2008 for 6 months. We're going to show, let's make that extreme, let's make that 2%, minus 2%. So here we're showing a minus 2% bias over a 6-month period in the middle of, actually it's 18 months, isn't it? It's from 2008 to 2009. Maybe we should make that just 6 months.
Okay.
So make that 2008. Okay, so let's have a look what happens here. So when we run this again now, we've generated a bias.
So okay, so this square here plots where we've applied the bias, doesn't it, onto the
Yeah.
real market data. So we see this.
Well, so it plots it on the real market data, but it's actually applying the bias to the random data.
Yes. So here we have the random data here, and at this point in time, the random series and this bias series are the same.
Correct.
But then when the bias comes into effect, we see the random series diverge from the bias, or sorry, the bias series diverge from the random series.
Correct. So you can see exactly there where the big yellow stream heads down
Yes.
south.
So this is this extreme negative bias we've applied to that random series, which has pushed it down.
Yep. But if you look beyond that rectangle, you can see that both bias series now
Yes, they're
map
the
each other,
same.
because we're using the same basic underlying
Yes.
data stream.
I see. So in our expert properties there, we defined where we wanted to apply the bias, which was a limited period. It's different within this period here where we've applied this bias, but then following on from there, it adopts the random series again.
Correct.
Okay.
So in this script, we've got the ability to create 5 of these random series. So let's reload that again, but this time grab that other set file that we've previously generated, and we'll talk about what that's all about. And Rich, you want to run through.
Okay.
Let's set to 25 there. Should that have been? Did we grab the right set file?
Let's have a look. Yeah, 25.
Okay.
We'll give it a run. Okay, so this represents a series that starts from 2010 right up to current day. It applies this randomisation to it. And we have 5 applied biases during that entire sequence of random data. We have a bias applied about 2 years after we start, between 2012 for 6 months, which applies a positive bias with a factor of 0.5 to that particular bias. Then it goes random again for a period until we get to 2014. For 6 months, we apply a negative bias of -1, which is a heavier bias than our prior 0.5. So we should get
in
that,
the other direction.
and in the other direction. Then it goes random again until we get to 2015, where we get another 6-month period of positive bias being applied. Then we go to 2016, where we get a very extreme negative bias being applied of -1.5, and then we go to 2017, where we get a very strong positive bias of 1.6.
Let's see what that looks like. So there we go. And there you can see the various periods of
Okay, so that's our first bias that's being applied to the random series, and we do see the separation between the bias series and the random series over this range. Then it adopts the random sequence. Then we have this negative bias where we see a big drop in our bias series with this applied negative bias against the random data. Then we see positive bias being applied during this section here, negative bias being applied here, and positive bias being applied here. Of course, we can set these bias directions to whatever we like, but it's impregnating this bias into the random series through this technique, isn't it?
Yeah, what we're hoping to demonstrate here when we look at running our EAs across this is to see whether that bias affects the way the EA operates. And by doing so, hopefully showing that it's the market data that actually indicates or dictates if there's any edge in your system.
Yes, I like the way as well we can apply this negative or positive bias, because that allows us with our trend following models, which are both long and short, to see the impacts of this bias on those trend following models. So this is a really good way to stress test our models in different regimes, which we can actually construct from ground up, as opposed to having to rely on the real market data, where we don't know which sections are random and which sections have bias in them. So this is a way we can test the efficiency of our models by deliberately constructing them in a way where we know where that bias exists, and therefore test the efficacy of our models and what happens over extended periods of random series to the nature of our performance.
So we might cut it off there, Rich, and let people have a play, and we'll come back in the next episode to show how we use this to demonstrate the operation of our EAs and how they might work with random versus real market data.
Sounds great, Fred, and thanks very much for this. This is going to be a very handy tool.
Catch you later, guys.
See ya. Bye.